Yesterday, out of nowhere, Google didn't launch Antigravity. Relax. But it did quietly publish research that made the internet immediately start saying the word anti-gravity anyway. Yet another example of Google research dropping something insanely technical, letting Twitter hype it into sci-fi, and then walking away. It is December 2025, and you're watching the daily dose of AI. So here's the context. Over the last year, AI labs have been moving past chatbots and into hard science. OpenAI is flirting with robotics. NVIDIA is selling physics simulation stacks, and Google DeepMind has been publishing paper after paper on AI-assisted physics modeling. This latest work focuses on physics-informed neural networks. AI models trained to respect physical laws instead of just vibes. And no, this doesn't make things float. Traditional physics simulations, like gravity, fluid dynamics, or energy systems, are brutally expensive to compute. We're talking supercomputers, long runtimes, and equations that don't scale nicely. Google's research shows that neural networks can approximate parts of these systems much faster, while still obeying known physical constraints. Not replacing physics, accelerating it. The models combine classical solvers with deep learning, letting researchers run complex simulations in a fraction of the time. Same equations, less compute pain, more iteration. Compared to traditional tools used in aerospace, climate modeling, or materials science, the advantage isn't accuracy, it's speed and scale. You can test more scenarios, faster, without waiting days for results. There's no pricing, because this isn't a product. No API, no launch page, no try it free. This is Google Research doing what Google Research does, publishing papers, open sourcing bits of code, and letting universities and labs build on top of it. And yes, people immediately jumped to anti-gravity because the work involves gravitational modeling. But manipulating gravity and simulating gravity are very different things. One is physics, the other is sci-fi with a Netflix budget. Still, the industry implications are real, and this also explains why Google keeps doing this in public. Publishing research isn't just altruism, it's recruiting, signaling, and setting the agenda. When Google drops physics-heavy AI papers, it's basically telling governments, universities, and enterprise clients, we own the tooling layer of reality simulation. Even if nothing ships tomorrow, everyone else now has to build around Google's frameworks, citations, and compute assumptions. This kind of AI-accelerated simulation feeds directly into climate forecasting, energy research, chip design, robotics, and even game engines. Developers don't see it today, but they'll feel it when tools get faster, cheaper, and more automated. The problem is, Google has a history here. For every TensorFlow, there's a graveyard of brilliant research projects that never escape academia. The tech is real. The follow-through is the gamble. So, the takeaway? No flying cars, no gravity boots, but a clear signal that AI's next phase isn't chatting. It's modeling reality itself. Smash the like button, subscribe for more tech reality checks, and tell me, is this the future of engineering? Or just another brilliant paper most people will never use?